So let's do a recap of whatever we learned so far. So why are strings in Java immutable? What does immutable mean? That once instantiated, once initialized, they can't be changed. So why is strings designed such a way in Java? So let's see, let's say this is the heap memory that we have, right? And in that we have stored a string literal Java or a string object. And this is basically the string pool. And this is being referenced by string 1 and string 2. So now if you change value for one reference, let's say if you change value for string 1 and you make it, let's say Java hello. If this is the value that you make now instead of this Java string here, so then string 2 will be referencing this value which doesn't exist any longer. Moreover, it will now reference the Java hello value, which will be wrong for string 2 because we only wanted to change the value for string 1. So therefore strings are created immutable. If you want to create a different string, you have to create a new string for that reference. So this is one reason why we create immutable strings in Java. Another point to note is every local string or other local variable type needs to be declared and initialized before using elsewhere. Otherwise they throw a compile time error. No operation can be performed on strings or any variable that is null. Null means no object. So basically no object doesn't have any properties. It cannot have any properties, right? Because it doesn't have any object. String literals versus string object. So points to note here is concatenation of string literals. Let's say one or two more string literals are concatenated, are added using the plus operator. Then that happens at compile time. So if you do u plus r, something like this, whatever example can you think of. So this automatically comes up to a complete string of UR, and this happens at compile time. Now if you do concatenation of string literal and string object, so let's say there's a string object b string which points to a string object, so basically new string hello. So now if you try to concatenate b string plus a string literal, let's say Vinay, so this does give us hello Vinay, but this happens at runtime. This computation is not done during compile time. This happens at runtime. Now concatenation of string object and a string object, this also happens at runtime. So let's say if you have two new string objects and you're concatenating them, that happens at runtime. So let's say b string plus c string, and this is also an object, new object, let's say h1. So this also happens at runtime. This doesn't happen at compile time. The other thing that we learned was, if we have a line like this, if you have a code statement like this, a string equals to new string last stop, and we try to add 1 plus a string plus 1. So what happens is this is written somewhat like this, 1 plus last stop plus 1. So in the back what happens is, since plus operator works from left to right, right? So it adds these two things first. So 1 is added to last stop, and then this and this are combined, these are concatenated, and 1 last of 1 is given as the final result. Another example to understand this is, let's say we have a string plus 1 plus 1. So you might think this will give the value of a string which is last stop, and then 1 plus 1 gives us 2, right? So it will give us last stop 2, but that is wrong. That does not happen. So what happens is, we have last stop here plus 1 plus 1. So first these two things are added. So this becomes last stop 1, an entire string, and then 1 is again added to this string. So this becomes last stop 1 1. So this is the output that we get. Note that assignment operator, this is evaluated right to left, and all other binary operators, this is evaluated from left to right. This is a very important part. So let's say you have a string a string, a string literal abc. This is computed during compile time. B string ab plus c, this will also be string literal and will be computed during compile time as abc. C string is a new string. It will be done during runtime, because it's creating a new string with the content abc, right? So therefore it's a string object done at runtime. So let's assume this is how it's written in the memory. A string is here, B string is here, both are pointing to the same letter stored at 101 address, and C string is a new object pointing at 105 address. So now if you try to compare A string, B string addresses, whether they point to the same address, since they are literals pointing to the same address, that evaluates to true. Now if you are trying to see the B string, whether the content of B string and A string is the same, the content is also the same, so both are ABC, so that will evaluate to true. Now if you try to compare A string with C string, this third point here, that will evaluate to false if the comparison is by double equals to. That is basically checking the address is the same or not of these references. Because C string is a string object created during runtime, it will be created at a different address, and A string was a string literal that was stored in memory during compile time. So therefore these two have the same different addresses, and therefore this produces false. Fourth point, their contents are the same, so therefore this gives true. Note that double equal to checks comparing addresses of the references, and equals operator that checks comparing content of the references. Another thing to note here is, and this is a special case I would say. So let's say if you have a string D string AB and string E string C. So let's suppose you're trying to compute D string plus C, the first case here. So you might think that D string is a string literal and C is also a string literal, so these all should happen at compile time, and this should match the address stored here at 101. This should basically point to the same thing, right? D string plus C. But what happens is D string is a variable, right? So its value is substituted AB. This is substituted during runtime. So until runtime, the program is not aware of what the actual value is, and therefore is not able to map this entire thing to address 101. So therefore, when during runtime D string plus 3 is computed as ABC, it is stored at a different address, let's say at address 103. And therefore, when we compare it with the string literal ABC, instead of giving true, it gives false because both the address are different. The string literal is at address 101. The D string plus string C that we have created, that is at address 103. So therefore, this gives false. For the same reasoning, if we do D string plus E string, basically adding two variables that refer to the string literal, even though they refer to the string literals, but they are variables whose value is substituted during runtime. So therefore, they will also give false in this scenario. Same reasoning for this condition here, and same reasoning for this condition here, the fourth condition. This will also give us false. However, when you have it something like this, let's say you're comparing D string and equal to with two different string literals. This evaluates to a string literal AB, and this is then compared with D string, which are at the same address, right? Which will definitely be stored at the same address. So let's say D string is stored somewhere here at address 102 AB. So this is where D string is stored. So therefore this gives us true. What is the conclusion of this discussion? So let's say if two string literals are being added and they are being compared with the string literal directly, this will definitely give us true, right? So string literal plus string literal, whether that's equal to string literal or not, this gives us true. In the second scenario, if we're using a variable for string literal and we're concatenating it with another string literal or another variable for string literal and checking whether that is double equals to string literal or variable for string literal, it will always give false, because these things are added during runtime, not compile time. But if we have it the other way around, string literal and a variable for string literal, if we're checking this, whether this has the same address to whatever we have on the right side, which is the concatenation of two different string literals, this happens at compile time. So if the content is the same, of all these strings, so then in this scenario, in the third scenario, this will always evaluate to true. Again, note that in this conclusion, we are assuming that content of all strings being discussed are the same.